what is constrained motion? So when I took the basic definition of a mechanism, what I said that a mechanism, it can be simply a combination of links, right, in which the motion of one link or rigid body, it is producing a constrained motion of the other. So constrained motion is simply means that if you simply turn one of the link, so the another link, it has to move in a specific fashion only, right? So the motion is not arbitrary, the motion is very distinct, it is well defined. So just remember this point. So now let us delve a little bit deeper into the constrained motion terminology. Then let us see what are the different types of constrained motion, right? So completely constrained motion, the first type of constrained motion is completely constrained motion, right? So here the motion between two elements of a pair is limited to a definite direction irrespective of the direction of force applied. So let us take one example. Again, I will consider the same example of a sliding pair. So again, here you have this rectangular bar as link 1, this rectangular bar as link 2. So now in this scenario, right, it doesn't matter in which direction you are going to apply the force, be it axial direction, be it lateral direction, right, or be it this direction, right? So it doesn't matter. This link 1 and 2, they will always have a sliding motion relative to each other. So such type of motion is called as a completely constrained motion. Now let us talk about incompletely constrained motion. So incompletely constrained motion, again, just remember this point. The motion is constrained only, but we are just adding one more word before this constrained motion term, that is incompletely constrained. So let us see what is incompletely constrained motion. So in this case, the motion between elements of a pair can take place in more than one direction. So the simple example is a shaft, a solid shaft rotating inside a hollow shaft, correct? So here you can see this cylinder, it can have a rotational motion and the same time it can have a translational motion as well, right? So here the motion between two elements, right, between these two links, it is in more than one direction. So one direction is the rotational direction, another direction is the translational direction. So such type of motion is called as incompletely constrained motion. Now let's talk about successfully constrained motion. So here, as the name suggests, that the motion between elements has to be made in a constrained fashion by some external means. Now let us see an example of a successfully constrained motion. If you see in the first picture, this is an example of a footstep bearing. Now here in this diagram, you have a shaft which is turning inside a bearing. Now in this case, if you see that the shaft, it can turn inside the bearing and at the same time it can translate along the vertical axis, representing an incompletely constrained motion. However, we put a force onto this shaft and we just restrict the motion of the shaft along the vertical axis. That means we are constraining the motion of shaft inside the bearing only in the rotational direction, and the movement along the vertical direction is being arrested. So this is an example of a successfully constrained motion. Now let us take the example of a piston reciprocating inside a cylinder. So if you observe, the piston can turn inside the cylinder or it can translate inside the cylinder. Now what exactly happens when we connect this piston to the connecting rod through a piston pin? So in that case, the motion of the piston, it is constrained in the vertical direction only. That means the piston is bound to reciprocate inside the cylinder and the rotational motion is getting arrested. So this is another example of a successfully constrained motion. With this, let us stop this session here and we will continue in the next session. Thank you.